Hey all dear students, this is Prajesh Chaudhary, Quantum Group. In the series of optical instrument lectures, in the last video, I talked about the human eye, its working and defects of vision and how we can correct these defects. In this video, we'll talk about the simplest optical instrument, that is the simple microscope, its working and its angular magnification. Before going further, we need to understand in general what is the angular magnification of any optical instrument. And even before that, we need to understand how we perceive the size of any object. So, for example, I have this pen, and when this pen is near to me, the size appears to be significant. But if this pen is taken away from me at a further distance, say 100 meter or 200 meter, this will appears to be like a dot, very small. The same object, when it is nearer to me, appears bigger, and when it goes away from me, it appears to be smaller. So it's not to the eye, it's not the actual size, but something else that matters for the perception of the size. So here is the diagram. See, this is the human eye, and this is the object in this diagram, and this is the object in this diagram. So both are the same object size, same object, and in this case, this object is near to the eye, and this object is farther to the eye. So this object is subtending angle alpha 1 at the eye, and this is the image. So image, this is the image. So this angle is alpha 1. And here in this case, this angle is alpha 2, this angle is alpha 2, and you can see this image is bigger and this image is smaller. So you can see that when the object makes a larger angle at the eye, the image will be appearing to be bigger, and that was when the object is at the smaller distance. So it is not the actual size of the object, it is actually the how much angle the object subtends at the eye. So if we want to magnify the image, we need to create something so that the image of the object that comes to the eye makes a bigger angle at the eye. So that's how we can magnify any image, and that is the basic idea of the magnification. So we'll not say magnification, no, we'll say the angular magnification, because we wish to magnify the visual angle subtended at the eye. So now let's define the angular magnification of a simple microscope. So to define angular magnification, suppose we have an object. So first of all, without any aid of the instrument, the object is placed in front of a naked eye at a particular distance LDDV. So an object is placed at a distance LDDV from the naked eye without the aid of any instrument. So that object subtends say angle alpha. Now with the aid of the simple microscope, the image of the object subtends at an angle beta to the eye. So the angular magnification is the ratio of these angles. So this is m. M is the visual angle subtended at eye with the aid of the instrument, and the visual angle subtended at unaided eye with the object placed at LEDV. So that is beta, that is alpha. So this m is beta by alpha. Now we have to derive the expression for the angular magnification as a function of at what distance the object is placed from the eye. So the first case, the object is placed in front of unaided eye at a distance LDDV like this. This is the object size h, and this is the eye, and it is placed at a distance d LDDV. So this object subtends angle alpha at the eye. So tan alpha is h by d, and the alpha is very small, so we can simply write alpha is equal to h by d, and obviously that alpha should be measured in radian. And now with the aid of the simple microscope or the magnifier, see, this is the eye and this is the simple microscope of focal length f. This is the same object of height h, and this is placed at a distance uo. See, when I write uo, that is the distance, double arrow thing, and if I have to write it say u, the x coordinate, that then I will write minus u. So uo is the distance of the object from the lens, And see the ray diagram, the one ray goes like this, and after this parallel to the principal axis, and after refraction that goes like this, and the other ray goes from this tip and through the optical center goes undivided. So image is the intersection of refracted ray. So these two refracted ray, the intersection is taking place at here. So the image of this point is this. So this is the image. So now the eye is here. So for this eye, this is the object and this is the image. So for this eye, after refraction, this thing is, so for this eye, actually this is the object, because there are two lenses involved. One is this lens, and then that is the obviously the lens of the eye. So for example, here this is the direct object, but for the eye this is not the object, because for this object through the lens the image is this. So for the eye, that is the image, and this image, this is actually the image for the lens, but this is the object for the eye, and this object for the eye is subtended angle beta at the eye. So through the lens we have magnified that this angle. So magnification is beta by alpha, and from this diagram you can see that beta is equal to h by u. So magnification, angular magnification is beta by alpha, so that is a d by u. This beta is h by u and alpha is h by d. H get cancelled, so it is d by u. Now there are two adjustment of a simple microscope. One adjustment is the final image. Image is formed at the infinity, and let's see this diagram again. If this image is formed at the infinity, so for this is the image of this, and for this image to be formed at infinity, this UO should be the focal length of the lens. So U is equal to F, and simply put in this formula, that was D by UO. This is D by UO. Now UO is F, so in this case the angular magnification is D by F. And then the image is formed at LDTV. So once again see here, this diagram would be better to, if this image is formed at LDTV, so that is a D, distance is D. So if I have to write for this diagram, U will be minus U and V will be minus T, and put that thing into the lens formula. There's a lens formula. V is minus D, U is U. U is actually this minus, this should be minus U. So here that will be minus D, and U is minus U and the thing, and if just multiply this thing by capital D, so D by minus D, D by UO, D by F, that will be minus 1. So we'll get D by UO is equal to 1 plus D by F, and D by UO is the magnification. So magnification in this case will become 1 plus D by F. So that is about the simple microscope. It's very simple thing. So thank you for watching. Stay tuned for the next.